Hi everyone, welcome to my first math quarter for Iter PowerPoint. In this case, we'll be talking about sets for the first quarter. Let's begin. First, what are sets? Sets in both math and the real world, or outside of math, are used to describe a group or collection of well-defined objects called elements. In this case, for real life, we can say a basket of fruits, for example, or in math, we can use a numerical example, like a group of even numbers. How do we describe a set? First, when you name a set, you have to use a capital letter, a single capital letter. For example, you can use A, B, C, etc. When making sets, use braces to encapsulate the elements, and make sure not to get the braces mixed up for parentheses. Example, A equals parentheses, braces, A, insert elements there. Now, if a set has too many elements, you can use an ellipses, which looks like 3 periods. It's all put together. There. Now look to your right. You can see an example. Well, you can see everything I just told you right now. There's the capital letter, enter, representing the set, and the braces. It says the elements within the sets, and even the ellipses. And for the next example, it talks about subjects in school. Math, English, art, history, science, music, for example. Now, how exactly do we make a set? You can make a set via 2 different ways. You either use roster method, which is also called listing method, in which all the elements are shown and listed separately by commas, or rule method, in which you use a variable to represent each element by explaining the connection between all of them. If you look to your left, you'll see an example. A and B show 2 different types of elements. A shows elements of weather conditions in the states. B shows the first 5 numbers of the numerical numbers, 5 numbers. Now, if you were to use rule method, you'd say insert variable here is what kind. In this case, A is the 4 seasons found in the states, and B is the first 5 numbers. Next up is cardinality of sets. Cardinality basically measure how many variables are in or elements are in each set. And finite and infinite sets are simple. Finite sets have a determined amount, while infinite sets go on forever. For example, A is a finite set because it only has a set number of elements, while B is an infinite set because it has an infinite amount of numbers that never ends. And then underneath the infinite sets is cardinality, as it shows you how many numbers are in those, or elements are in those sets. It's A has 3, B has an infinite. Next up is subsets and universal sets. A universal set is basically a very, very large set that contains smaller subsets. And subsets are sets that contain the variables or elements that are part of the universal set. For example, U here is basically any odd number, while the subsets included O, E, and P all include odd numbers like 1, 3, 5, 7, and 9. You can also use a Venn diagram to represent sets. It's basically a graphical representation of sets using geometric shapes such as circles. And when you make these circles, you add the elements in them. But then this leads us to the next part. Intersection and union. For intersection, it's basically the intersection of 2 sets. It basically means that you have to find a number within both sets that are the same. Like, for example, you had, or I'll show you later. And union involves the combining two sets by combining the elements in both sets to make one huge set. Okay, here are examples. Let's say you had these 3 sets, A, B, and C. If you want A, B, the intersection symbol is represented by an upside down U, and if you wanted to intersect A and B, find a number that's the same in both. In this case, 20. A and C's common number is 12, but because B and C don't have any number that's the same in both sets, you just put nothing in it. So if you ever encounter an intersecting number with no common numbers or elements, just put nothing in the parentheses. Now for union, it's much more simple. Just add all the elements in the set in ascending order. That's very important. As you can see with A union B, A union C, and B union C. Now let's get back to the Venn diagrams for examples. Get those 3 elements or sets from the last example, and and write them in Venn diagram. When writing intersection of sets, you want to write it like this. Draw two circles and then put the elements of both sets, label them, and then put the elements of both sets into the circle, into the labeled circles, based on where they belong. If there's an element, if there are one or more elements that are part of both sets, you combine both sets together, circle sets together to make this little middle where you put all common elements that are found in both sets. It's like, for example, A union B has 20 in the middle, A intersecting B has 20 in the middle, and A intersecting C has 12 in the middle. But because A, B, and C don't have the same elements, they're just two separate circles with their own elements. But now, if you want to make union, it's simple. All you have to do is just highlight all the numbers in both sets to represent that they're all part of the same set. And also make sure to follow the intersecting rules if there are similar elements in both. And now we get to the questions. Let's begin. Now here's what we're given. We're giving three sets. One set has a group of even numbers. A group of even numbers that are less than 10. So 2, 4, 6, 8. B has a group of numbers that are odd and are less than 20. So 1, 3, 5, 7, 9, 11. Make sure to write these in in ascending order to not mix them up. 11, 13, 15, 17, 19. And then C is just a bunch of random numbers spliced together. There 5, 9, 8, 15, 17. Those are your sets. Now the question is asking us to find three things. What is the intersection of A and C? Of A and C. So intersection means two variables or two elements that are part of both sets. A contains even numbers that are less than 10, 2, 4, 6, and 8. And would you look at that? We found a match. 8 is present in both A and C. So we write that as, when writing solutions, write it like this. So the intersection of A, write the intersection symbol, and C equal, put in the braces the number that's part of both, 8. Now, for the next one, it requires combining elements of both B and C. Since we already know, now, there are some elements of C that are also a part of B, and if any numbers in either sets are also intersecting numbers, you only need to write them once. And you also have to do it in ascending order, like this. So, B, U is usually the union symbol. C equals. So starting from B being an odd number that's less than 20, it's 1, 3, 5, which is also part of C, so we don't need to repeat that twice. 8, because 8 also part of C. 9, 11, 13, 15, and 17. So 15 and 17 are also part of C, so you don't need to repeat that. And this is your union set. Now for the final question. A intersecting B. Since A is a group of even numbers and B is odd, there's no connection as both will never find a number that's the common ground. So, and what do we do whenever we find two numbers that are intersecting that don't have a common element? Simple. We write this. A intersection B. Wait, why is that? A intersection B equals nothing. Just write nothing between the two braces, and that's your answer. It's your answer. Now let's move on to the next question. Wait. Just erasing here. And all done. And now the question is, a pizza chain is willing to pay 0.75 to each person interviewed about his or her likes and dislikes of types of pizza crust. Of the people interviewed, 220 liked thin crust, 270 liked thick crust, and 70 liked both, and 50 did not. What was the total cost of the survey? So we'll use Venn diagram for this one. And create two circles, and label them. N. Oh yeah, so we'll use N for the number of people who like thin crust, and we'll make another circle here, make sure to intersect them since they have some people who like both, and C for thick crust. Let's take how many people, since 70 people, put 70 in the middle since 70 people like both. Subtract 70 to the 220 who like thin crust to get 150, and subtract 70 to the 270 who like thick crust to get 200. Oh, and then just add add U here to represent the 50 who don't like pizza at all. Now, all we have to do to solve this is simple. To get the cost is equal to 0.75 times the sum of all the people. So we have 150 for the thin crust lovers, 70 for those who like both, 200 for those who like thick crust, and then the 50 who didn't. If you add them all together, it should give you at least 570. So wait, I gotta erase here. Oh, so yeah, which equal to 570. 570. That's how many people the pizza crew interviewed. Oh yeah, so if you add these numbers together, it'll give you 570. Now that you know how many people the pizza company interviewed, all you have to do is wait, yeah, I gotta erase everything first. All you have to do now is multiply 0.75 by 570. It's simple. Well, make sure to apply decimal rules here. So 5 times 0 is nothing, 5 times 7 is 35, 5 times 5 is 25, plus 3, carry over 3, you get 28. Now we move down. 7 times 0 is also nothing, 7 times itself is 49, 7 times 5 is 35, carry over the 4, you get 39, and then 0 times everything up here is just 0. So when you do the math and the addition, 17 goes here, move the 1, and oh, sorry. Okay, so 5 goes here, this becomes 17, carry the 1 here, this becomes 12, carry the 1 here, you get 42,750, or, yeah, that's the cost. So the total cost that the pizza company owed to everyone was at least is 427,500. Oh, whoops. Sorry, I think I made a mistake here. Hang on. Sorry, I made a mistake here. Let me try that again. If you were to add the number of people who like both, 350 you get from adding 500, 150, and 200. Then you get the 70 from the people who liked both, and the 50 who didn't like them. You get 470. That was sorry, I made that error by mistake. Now all you have to do is multiply 470, which is the people who the pizza company interviewed, by 0.75 to get your answer. So if you do the math correctly, so this is 0, this is 35, carry the 3 here, you get at 23. This is also 0, get 49, move the 4 here, you get 32, and then all these is 0, you should get your total, which is exactly 353,525. Oh wait, sorry. 352.50 because of the decimal here. Whenever you have a decimal, oh sorry, dollars. Just make sure to add the what type we're looking for too. And thus, this is our answer. And with that, this ends the PowerPoint. Thanks for oh yeah, thanks for listening to my PowerPoint and for bearing with me when after I made that mistake. Sorry. I hope you have a good day. Bye.